Hey guys, welcome to part 2 of algebraic fractions for A-level maths. In this video, we are looking at simplifying an algebraic fraction. So, when we're simplifying these bad boys, we are taking out every common factor from each term and writing our answer as simply as possible. So, let's get cracking. Okay, so first of all, let's just start with a non-algebraic example, just to illustrate what we're doing. So let's say we want to simplify 24 over 30. So, we're not going to do this using the biggest common factor. We're going to take out a factor at a time. So, both of these numbers are even. That means we have a factor of 2. So we can divide the top and bottom by 2. We're going to get 12 over 15. We then got a common factor of 3. So we're going to divide the top and bottom by 3, and we get down to 4/5, which is the fraction in its simplest form. Now, why did I do it like that? Well, to illustrate that you don't have to take out the biggest common factor straight away. You can build up, take out one factor at a time if you find that easier. So, now we'll get the algebra involved then. So, example 1, we've got 4x minus 10 over 6x. So, when we're dealing with algebraic fractions, it's very important to enforce the fact to be able to simplify them. Every single term has to have the common factor. So here, what's common between 4x minus 10 and 6x? Well, it's 2. So we can divide here each term by 2. So 4x divided by 2 is 2x. Minus 10 divided by 2 is minus 5. And then 6x divided by 2 is 3x. Now, a very common cock-up in maths is people will then look at this and go, well, I've got an x on top and an x on the bottom. Surely they cancel out 2. That is not right. The x is not common to every single term. So we cannot simplify this any further. This is our final answer. Okay, next up we have x cubed plus x squared over 2x to the power of 5. So, hopefully we're quite happy here that we have a common factor of at least x running throughout. So, we could divide through by x first of all. That's going to leave us with x squared plus x over 2x to the power 4. We still have a common factor of x in every single term, so we can divide through again, which is going to leave us with x plus 1 over 2x cubed. We could also think about this one by factorising. So let's say we looked through it and we saw, well, we got x cubed, x squared and x to the power of 5. The highest common power of x there then is 2. So x squared. So our actual highest common factor was x squared. So we could have first of all thought of it as x squared times x plus 1 over x squared times 2x cubed, like that. We then got our common factor of x squared, so it does again indeed go down to x plus 1 over 2x cubed. So it's often a very common necessity that we do need to factorise these guys first of all, to be able to simplify with that one, we didn't necessarily have to. Remember, if you can spot the highest common factor, you don't have to do it bit by bit. I'm trying to make things as simple as possible, hopefully to help you get your confidence up. Okay, on the next. Okay, so here then we've got x plus 1 over x squared plus 3x plus 2. So, as it stands, none of our terms have a common factor in them. So, from the get-go, there is no simplifying we can do. What can we do? We can factorise. Let's see if we've got a common factor if we write everything in factorised form. So, the top is as simple as it can get. It can only be written as x plus 1. So the bottom there is a quadratic. So we can factorise this guy. We would actually get x plus 1 times x plus 2, like that. Now you can think of the top as being in brackets if you like. So we can now see we do have a common factor of x plus 1 on the top and on the bottom. Now, when we divide that away, we don't get a 0 on top. Remember, x plus 1 divided by x plus 1 is going to leave us with 1. So we're going to be left with 1 over x plus 2. So with that one there, we did have to factorise before we could simplify, and that's a very common thing that we have to do. Okay, final example for this video. In the next video, we are going to be looking through example questions where we're going to be adding and subtracting and simplifying these bad boys. Okay, so 4x cubed minus 9x over 2x cubed plus 5x squared plus 3x. Now, first of all, let's check through for any common factors that we can get rid of. So, every term here has at least one power of x. So we can divide everything through by x, first of all. So that's going to leave us with 4x squared minus 9 over 2x squared plus 5x plus 3. Okay, so that's taking care of a common factor. Now as we stand, we've got no more common factors that we can divide away yet. What do we have? Well, we have a quadratic over a quadratic. What do we like to do to quadratics? Factorise them. So, this guy up on top is making another appearance. It's a difference of 2 squares. How do we spot that? We got 2 terms, we got an x squared term, minus another term, that makes it a difference of 2 squares. So, to factorise the top, we get 2x minus 3 times 2x plus 3, like that. Now to factorise the bottom, well, we know that we need to be able to simplify this fraction, so that means one of these pairs of brackets is going to have a 2x in them. Which we sort of already knew as well. It's the only way that we can get 2x squared without getting square roots and stuff involved. So we're going to have a 2x times an x. Now we also know the 2x bracket is going to have the 3 in it. If the x bracket had a 3 in it, then we wouldn't end up with a common factor. So it'd be a pointless question. So we're going to put a 3 in here, which means then to get the 3 at the end of the quadratic, we're going to have a 1 in there. Now, everything is positive in this quadratic. So it's 2x plus 3 times x plus 1. I like that. Now that we're in factorised form then, we can check to see whether we have a common factor or not. We do. 2x plus 3. Ideal. So if we divide those away, we are left with 2x minus 3 over x plus 1, which cannot be simplified anymore. That's our final answer. Okay guys, that's enough fun for this video. Hope to see you in the next one.